the middle curve here. So I'm going to go back here. And on the offset, what I would do is that I'm going to explode the curve that I have. So it's going to go back here. So the offset input was the objective 260, and each of them was 1. And then the outcome will be the segment of each of those segments that I had before. Now, thing is that, let me see what a mistake I made here, because some of it shouldn't be 5, it should be 4. Oh, sorry, yeah, that's correct. So it's 4 segments right there. Now that I explode them, this is going to be my first object here. Now, I want to basically merge this like line together, so I'm going to use the merge. And I'm getting the first segment here, putting it in this part. And the second, like a merge component, will be the edges that I get from the breadth, which is going to be that second object for doing the loft here. Now, if you look at this, you see that here I have 1,040, and each of them are basically 4 segments in it. In the other one, what I have is 1,004, and they are 4 as well. But what I want to do is basically doing the loft on each individual of them. So I have to graph the data before I go into the loft itself. So I'm going to open this and then make sure that it's graphed here, and do the same thing on this part. So let's take a look at the data before and after we do this. So here is going to be my source data. So this is the segment. I have 4 on each of them. Now, what I do when I put this here, let me just put this here, and then put the graphed tree, and connect this part here, and put another visual here to see what's the difference. So now I have each of them to be on one branch of the data, each of those segments. How about the other one? So the other one, when I connect it from the breadth, you see that each of them was on 4 branch, each branch has 4 items on it. After grafting, I got each branch 1 item, meaning that when they perform the loft, it's going to be connecting 1 item from this to the other one. So let's do this part now. Now that we know the grafting part, let's go here and then use the loft. And then connect that part to here. It's going to take a while for my computer. Okay, so what I want you to do is that just select everything else that you have here, and then hide them so you can see the result. If like a mistake that I made was that when you look at the data that goes into the loft, it's basically 1 data on each branches, and in order for loft to operate, it needs 2 data on each branches. So here, what I will do is that I will basically simplify the data because it didn't combine the 2, and then this create these branches that has 2 data. So the problem was that with what I had before was this, and this is the important part, because if you look at the data structure, let me zoom out here. What I had here, I have 0, 0, 0, and then there was a 1 here. Now look at the data structure from the other one. It's totally different data structure. The format was right, but the number of branches was wrong. The number of indexes was wrong. So when I combine the 2 data, it gives me 1 data on each branches, 1 curve on each branches. So the simplify, if you recall from last session, when we do the simplify, what I get from it. So let's try to do the simplify before connecting it. So I'm going to do the simplify tree, and I'm connecting it here to connecting this part to here, and then take a look at the data structure now. I got the 0, 1, 0, 1. That's the simplification in terms of the indexing of the data. And I will do the same thing on the other side. Look at this data structure here. I will put the simplification, and then you see that actually before grafting. Let's graft it here. When I graft it, it's just like a giant data structure with so many indexes. By simplifying it, the data structure between these two are now similar. So now when I perform merge here, the merge basically getting the index data from one, which is one line, same thing from the other side, and combine them together. So now in each of those branches I have two lines, not one line. And now Loft can perform what it's supposed to do. So let me delete this part, and then this part, we don't need them anymore. And I undo this grafting part and enable this. So if I go back here, you see that I did the Loft. So these small pieces is kind of going like this line with this one, and then this line with this one, and then create this like a surfaces all around this part. Okay, great. Now that I have that part, the other part that I'm looking for is basically going back to my original data, which was all these paneling that I create, and I find the center point of that panel. Because what I want to do is that I want to scale this whole thing. I want to scale these line here to make it smaller so that I can shift it down and then create this. If I zoom in here, see that. I want to scale the central part, this curve here, scale it down, and then move it all the way down. So what I need is figuring out what is the center point on each of these panels. So where are the center point? The center point exists in where I have the first surface, so which is these subsurfaces here. I'm going to take the subsurfaces and I'm going to use the evaluate surface. Now, one of the things that you basically can do when you are organizing your basically form or like a work is that you can actually bring, let's say for example, I'm bringing the surface here, the surface component here, and I'm connecting it here, and basically I bring this all the way to here, this part, and I rename this. So I'm going to rename that. I'm going to call this subsurface. And in terms of the wire connectivity, I will just right click on the wire and make it hidden. What does it do is that sometimes I need some component or some data from the beginning of my like algorithm, and if I start connecting all these things, it's going to be super messy. But I want to know where I got that specific data. So I create this bring this like a input data, connect it to that, and then make that a line hidden. So now when I want to connect this subsurface here, later on I have this idea that where this data coming from. So I have that. Now I need the UV value. So what is the UV value? We are going to use the MD slider, right? So we go with the MD slider, and I'm going to connect the MD slider to the UV value. I just reparameterized my surface. I did it before, but I'm just making sure that I'm making it correctly. Now that I have that part, I got the center point, right? This is the center point with all of this, and also I got the normal. I'm going to use normal later on. For now, we just want to use this scale. So for this scale, what I want to use is that I want to use these basically the curve that I have at the beginning of the explosion here, right? So I'm going to use that scale. I'm just using it here, and I'm going to use a scale, not UV1. Scale. These are going to be my geometry. Just going to bring that in here. The center is going to be the point that I have here. So that's going to be my center point. And for the scale factor, we can go with like maybe 0.6. Now let's go and check the geometry, see how it's look like. Have to zoom out, see. Let me just turn this off, because that preview is just not the work, but preview off. Just gonna turn the preview off so we see what we have here. Okay, probably made a mistake in terms of what I connect for the scaling. This has to be the scaling, either the curve itself or the offset. Let's try it offset. Okay, just gonna, so here we have 260, we have 260. What mistake I'm making right now? Any guess? Why am I getting this result? It goes back to the data structure again, right? So the data structure I got from the geometry, these are all like on each like a graph on the like a basically branch of a data. Here, what it does is just get one data from the first branch and run it 260 times, and then do the second one. So if I graph this data, I would get this result, because it takes the center point from one and then run it on the first branch and then do the second one on the second branch. Makes sense so far? So it's whenever you got some like a unexpected result, you have to pay attention to the data structure itself. Now I have that here in terms of the geometry. I want to move this because I'm trying to achieve this movement in the middle that goes in, right? So let's go back to the Grasshopper again, and I'm gonna use the move, right? Now, in terms of the translation vector, what is the translation vector I'm gonna use? It's gonna be the data that I got from the normal, right? That's gonna be my data to use. Now I can use the multiplication to increase the value of it. So I'm going to use the multiplication, put 0.5, and using that normal as the translation, and then just connecting it here. Again, what I have to do is that I have to make sure the data that I'm connecting is grafted, because the data that I have here is grafted. So if I go back, you see that now I have this surface. It's kind of going beneath this. I can make this a little bit smaller. So let's go for maybe 0.4. I'm looking at it. It's closer to the surface itself. Great. Now, what is the next task for us? We are trying to make a surface out of this, right? So we want to use the loft. If I create the loft, I will be good to go. What are the two objects that I have for a loft? One of them is this, the original geometry that I got from the offset here, right? And the other one is the one that I just scaled it. Again, I want to make sure that I'm basically connecting the right data together. So here, what I would do is that at first I'm going to explode this data. And this is going to be segmented of the same data. So it's going to be 4 segments here. Now, we want to use the merger, right, to merge. And the segments will be these segments that we had before. So I'm going to bring this segment here. And then let's do the same thing on this side. What did we do last time? We basically get the segments. We graph them. So we put them on separate branch. Do the same thing here. I'm going to make sure that it's grafted as well. And now we simplify the data, because we know that if we don't simplify it, it's putting them on each separate basically branches. Now when I'm looking at it, I have 20,000 data points, but they are break down into like a branch of 2. So let's put the data place here and then take a look again. So in each of these branches I have 2. Now if I do the loft, that should give me a right loft that you see here. So let's take a look at the things that we have. So I'm gonna hide everything except the 2 lofts that I have so far. Turn you off. And going back here, and I have this like a nice surface that I have before.